Hello everybody and welcome to this week's Hubble Hangout. My name is Tony Darnell. I work at the Space Telescope Science Institute. And this week we are continuing our celebration of 25 years of the Hubble Space Telescope by, we're going to be talking a little bit with author Carolyn Collins Peterson on the history of Hubble, as well as Dr. Antonella Nota from the European Space Agency, who will give us insights into the European Space Agency's role in the history of Hubble. But before I do that, I've got to let you guys know we hope that you will send us questions and comments during the Hangout in the following ways. Tweet at us. You can tweet at us using the hashtag Hubble Hangout, as always. We're also the easiest way is to also just use the Q&A app, as well as the comments on the YouTube channel this is being broadcast in. So please feel free to leave us questions and comments throughout, and we will get to them as they come up. And also, if you have not subscribed to our YouTube channel, we hope you'll do that. It's Hubble's site channel. Also follow us at Hubble Telescope on Twitter. Okay, so joining me as always is Dr. Carol Christian. I'm going to do this throughout the Hangout.
Are you breaking in a new set of lips over there?
Carol Christian, the outreach scientist for Hubble for the Space Telescope Science Institute.
Hey there.
And Scott Lewis, our driver of the Internet extraordinaire. Welcome back, guys. It's good to see you again. So, as I mentioned before, we have an author and a scientist to talk about the history of Hubble, but there is also an opportunity coming up next week for you to participate in the 25th anniversary of Hubble Space Telescope. The European Space Agency next week is launching a video contest to allow you guys to express yourselves and to get involved in the celebration of Hubble. And Scott, I believe, has a trailer that he's got queued up.
Oh, yeah, I'll do that now. I didn't know we were doing it so soon. Just one moment.
To celebrate 25 years of a truly remarkable telescope, its staff and its fans, we're pulling out all the stops for 2015. Join us by being part of our biggest competition yet. Ode to Hubble will launch early next year and give you the chance to get creative and show how Hubble has inspired you. As long as it can be uploaded as a YouTube video, you can submit anything. Pan over a drawing, scroll over a poem or text, film your own Hubblecast, create an animation, or record yourself performing, composing music, or vodcasting. Just make it innovative, creative, and most of all, inspired by Hubble, one of its great discoveries, or one of its stunning images.
So there you go. There's the trailer for the contest. It's going to be launched next week. You can watch the full video over on spacetelescope.org. They have a Hubblecast section, which comes out How often does Hubblecast come out, Antonella?
You know, when we have material to show something around, pretty much every other month. We have 81 in the library so far since the beginning.
So these are really nice videos that sort of keep you up to date on Hubble news and all kinds of cool things. But this one is the one they made last year. It was made in December to sort of get people ready for this video event. So we hope you'll participate, and we hope you'll go looking for the information. In fact, Antonella, let me bring you in on this. How can people learn more about this contest?
Well, there is a website, ESA Hubble, www.spacetelescope.org. The people should look, and there will be instructions. But basically, the competition is opening on Monday. Will be open for a month and a half. And our hope is that people will respond and will be able to have a great selection of creative videos and music and paintings, because we want to select the winner and announce it, actually 2 winners, on Hubble birthday. And the winners are, you know, there is a general category winner and there is an under 25, because we felt it was really important to see what the next generation that is born, who was born with Hubble already in orbit, thinks of this amazing telescope.
Right.
And,
we're calling them the Hubble generation, right?
the Hubble generation. And we also have some exciting prizes. So I hope the people will be encouraged to participate, because they can win actually pieces of the actual solar arrays flown on the telescope between 1990 and 1993. So it's very interesting.
So these are actual Hubble artifacts that have been brought back from space after a repair mission.
Yes, this because Hubble contributed a pair of solar arrays. They didn't work, as expected, so they were removed and substituted, and they were tested extensively on the ground, because it's interesting to see how they were damaged by meteorite impacts. And so one of the arrays that was already, tested and pretty much cut in pieces for the testing, we decided to use the remaining to produce some little interesting mementos that will be presented for the celebration on, on the 23rd. And the winners of the competition will enjoy some of those.
So my question is, can I get in on this, since I'm technically a contractor and not an employee of Hubble?
Of course you can.
I like this. I like this.
Now you're up against Scott, people.
Watch out, Internet.
Watch out, Internet.
I want a part of this.
Yeah, I'm not going to be entering, but I have also done quite a few Ode to Hubble videos myself. In fact, the very first one I ever made, the very first video I ever made in 2006, was called The Most Important Image Ever Taken. It was a tribute to the Hubble Deep Field. And I'm working on one right now with an intern who is almost finished, called The Most Important Instrument Ever Built. So that'll be coming out on Deep Astronomy, and I just wanted to give myself a shameless plug there, because that was
very shameless plug.
Yeah, but I do this all the time. I'm used to it. I can't say enough good things about Hubble, and so this is your chance, folks. Next week it opens at about 8. I think you said 8 a.m. Eastern time in the United States, right? That's when the web page will begin. Okay,
yes.
so and you can. How do you submit things? Do you upload videos to YouTube and tell people about it, or how do you do it?
Yes, you basically submit a video, and the video can be everything. Can be yourself recording something, can be you showing playing a piece of music, or panning over a drawing, but it has to be in a video format. And the items that will be submitted will be crowdsourced. And then the finalists will be judged by a panel of four people who will have the tough task to select among the very top finalists.
So how does that work, crowdsourcing? How will that be handled?
Basically, we will let a few submissions going for 2 or 3 weeks, and then we'll open for crowdsourcing. So people will have a subset that basically a large set they will be able to vote on pretty much as they like. So,
okay, so you'll just be you'll be counting votes on different videos, and whichever ones some say gets the most votes, then the panel will decide. And you've got a panel of Hubble scientists that are going to be looking at these, right?
Yes. Well, it will be a sort of mixed panel. We have. I will be on that panel. We also have Lars Christensen, who is the ESA of our, the head of our ESA Hubble outreach effort in Europe. We will have Ken Semba, the head of STSCI Hubble Mission Office. And we thought we needed to have a different perspective, so we asked Rebecca Alban Hofberger, the director and founder of the American Visionary Art Museum in Baltimore, to provide a artistic perspective to
nice.
Sounds good. It will be an interesting panel, and we'll see what we recommend.
All right, and Carol, maybe we ought to have a hangout with the winner or something, and see, or some of the winners.
Yeah, absolutely.
Because I'm going to win, so I'm here.
Yes.
Right?
Oh boy. All right. Okay. Well. Fix. Maybe.
Okay.
I'm just trying to raise the standard of everyone around. Come on, everybody. Let's do this.
Yeah.
Well, I can tell you that we tried a similar competition a few years ago. It was called Hidden Treasure, and it was a sort of experiment. We were expecting like 500 entries, and we were expecting to be done in a month, and we got 2,500. And we had to even extend the judging time, and we're still using the images today that people produced at the time. It was just incredible. So
yeah, I thought that was a really interesting contest, because that's where you had people go and look for sort of unknown or not well-known images and bring them.
Oh.
Yes. Yes.
Okay, so let's move on to there's your chance, folks. Here's your opportunity to get involved in helping us celebrate 25 years of the Hubble Space Telescope. Speaking of which, it's been up there for a very long time, and we've got people here who've also been involved with the project for quite a while. I have my good friend, she's an author, Carolyn Collins-Peterson. She's from Colorado right now, looking very sunny right now.
Yeah, sort of. Actually, it's going to snow.
Oh, is it going to snow?
Yeah.
Okay. And she's written several books on Hubble, and so welcome, Carolyn. And I guess I'd like to get your insights into some of the work that you had done starting out in your career with Hubble.
Well, I first was on the team right about the time of launch. I was working on the Goddard High Resolution Spectrograph team, and that was headed up by Jack Brandt and Sally Heap, who I believe just retired from Goddard, but they were sort of co-heading the team. So Jack was at the University of Colorado, and I was working for him on that, and also on another research project having to do with comets, which is another one of his interests. So my original job was going to be to, when the data started coming in, to have some role in analyzing that data. When the Hubble Space Telescope was found to have spherical aberration, everything kind of ground to a halt, because the SA really affected our instrument. So we kind of had to wait. We had to kind of sit and wait for some months until we could figure out, until people could figure out how we were going to handle our data, what we were going to pull out of it, the deconvolution algorithms. So for a while, I didn't really do much of anything but sit there and watch the firestorm break out. And I took a lot of notes about that. And that's sort of one of the reasons that led to my book.
Okay, and so describe us your book. This was you've written, I think, two, right? There's Hubble Vision, and then there was one before that, correct?
No, Hubble Vision was the first one. There were two editions of it. Actually, can you see this? That's it? Yeah, that's the first one.
Yes.
This is apparently a collector's item. And so what happened with that was, about August of the year that we had spherical aberration of 1990, so that was discovered and announced in June, I think, is when the firestorm broke out. About August, I started seeing really good, not really, but good science coming out. I think the first thing was a picture of Saturn. And Jack and I and everybody on the teams knew, well, there's science being done. You know, the thing wasn't dead in the water. It was stumbling around, you know, with a sight problem, but it wasn't dead in the water. So I started taking notes. I started collecting every little bit of data that I could about the science that was being done. We weren't doing a lot. We were doing some. I believe the what was John Bacall's instrument, Carol?
The wide-field camera.
Wide camera.
Well, no, the wide-field camera had problems. But the other spectrograph was having problems as well. And so, there were just problems all the way across. And so I just started collecting it all. And in the meantime, I also started watching the media, how the media was treating it. And of course, you all remember, if you were there, what the horrible, horrible stories were, the headlines. It just, you know, the Hubble techno-turkey, you know, David Letterman had something new. I mean, I did a search on it was Nexus, the news gathering service, and there were something like 11,000 hits of stories that were done on the Hubble Space Telescope, and about half of those were mentions on David Letterman. You know, people just repeating what he said. And so I started watching that, and science I'm collecting, and then I'm sort of collecting this media stuff. And at the time, I was working on a master's degree in science journalism and telecommunications engineering. I was thinking I was going to go into radio astronomy or something like that. And so one of my people in the other department said, well, you really ought to keep track of this. And so we did. And that was ultimately what became my thesis for my master's degree. And that was called the media treatment of the Hubble Space Telescope. But that was 5 years of data that I took.
What year did that come out, your thesis?
1996.
So 96. So there had been a repair mission done by then, and so things had gotten fixed. At least a lot of things had been addressed. So that you bring up an interesting point that I want to kind of go with a little bit here, and that is the cultural impact of Hubble. And you are in a position, I think, to really give us some good insight on it. You were in on the beginning when the public was, maybe the conversation was much more negative. I think we all agree now that is not the conversation with Hubble and the media, and certainly not with the general public. What do you think has been mostly responsible for that change?
I kind of addressed that in my thesis a little bit. A lot of it was, it was hard to say at that time when I was writing the thesis exactly what all the factors were, but I addressed the one issue was the continuing drumbeat of science coming out. Every time there was a pretty picture, I like to think that one nasty headline died and went to heaven, because it basically removed a little bit more negative. But in the beginning, we had people like Barbara Mikulski saying the things that she said. In the background, I was talking to mission scientists, Sandy Faber and people like that, who were saying, okay, we know what the problem is now. We know what it is, and so we can get our hands around it and we can fix it. But even then, I knew that there was a lot of debate inside the community in those first couple of months about what was going to be done. But every time a good picture came out, every time that there was a positive story, it would change the conversation a little bit. However, for about 4 years, every single time there was a story that came out, you would see Hubble sees great picture of whatever. And then at the very bottom of the story or somewhere in the story, the media would say, but you have to remember, they would say something like, remember this was the Hubble, $1.5 billion Hubble that had all these problems. They would remind you of the problems. As soon as you'd say something good, they would want to remind you, but remember, it had problems.
So this happened well after it started doing some really good work then.
Oh yeah, but it was a slow process. I traced stories for about 5 years using Nexus, and just looked at all of them. And you could sort of almost graph this very smooth curve of positive stories going up and negative stories going down. But there was this long period where every time they said anything, they'd have to bring up the bad stuff.
Yeah. So
and it was always the price first.
Yeah, you got to have
the
the
price first
on
yeah.
there too. Yeah, it's funny how with most NASA, almost anything, they always have to say what the mission is.
Yeah. You don't see that with Rosetta.
Yeah, right. So Jonathan Eisenhammer, hi Jonathan. He's a coworker. He is on the Q&A app. He said the other spectrograph was the faint object spectrograph.
Thank you. I was spacing it out. Thank you very much.
Yeah. Okay. So
aren't we all spacing out though? I mean, really?
That's true.
Well, got our space on.
That's what we're here for.
But Carolyn, I just want to say I don't think it was limited to 5 years. Even after the fifth servicing mission, people are saying, "Oh, does it work?" It's like amazing. Yeah. It's amazing.
Yeah,
anyway,
that's true.
I
was tracing it through the media, but you're right.
Yeah.
I do a lot of public talks, and I will still get questions from people. So how did they fix it? Or is it fixed, or is it still
working?
working?
Like, who cares?
It's working!
It's great, actually. So
I think not only is it working, it's doing a phenomenal job. It's doing something it was never intended to do. Like Frontier Fields to me blows me away on what we're able to do.
Well, I actually, we all sort of have this perspective that, I remember the American response. So Antonella, I'm actually interested in what the European response was, because I don't have much insight into what was happening during that time.
Well, it was actually,
I don't want to dwell on it, but it'd be interesting.
It's interesting because I was actually here, so I had more exposure on the American side too, because I arrived in '86 working on this project. So as Caroline said, I lived I was working on the faint object camera, which was the European contribution, and we were all living through those horrible times, right, where the press was negative and everything was very negative. But the only one thing, and yes, the press continued to be negative for a while, but on the other hand, I think that what was remarkable, and that in a sense to me started changing and turning around the feeling of people, is the amazing job that the astronauts did in orbit with the first mission. I still remember watching that and being glued to the screen, just watching these people performing this amazingly complicated task with the needs and like making them seem so simple, like they were working in their backyard. And I think that really, and the visibility that Servicing Mission had, you know, with the public and with the audience, they were all saying, well, will NASA be able to fix this, or we're doomed with the techno-turkey? I think that really changed the history of the project, and also, in a sense, re-established NASA's reputation at the level that was incredible. I mean, people acquire so much respect for an agency that could, you know, put it together and deliver, you know, in such an astonishing fashion. And then when the first image of M100 came down, and the comparison between the pre-spherical aberration and the corrected image, I mean, it was just, I remember the wow in the room. It was just incredible. So that is when, you know, the tide changed.
I mean, particularly in the astronomical community, because I think at that point I had just joined the American Astronomical Society as a student member, as a graduate student, and at the meetings you still had people in the very beginning saying, you know, we've wasted this money, we could have put it elsewhere, this sort of attitude. And then when that first M100 picture came out, and then later on when the Deep Field picture, I think there was nobody that believed anything differently after that.
Right. Yes.
So Judy Smith has a comment, Schmidt, I'm sorry, Judy Schmidt. Hi, Judy, by the way. I'm over 25, but it feels like Hubble has always been there for me. I was always too young to watch the news or care about Hubble's eyesight problems at the start. It's almost like it never happened. And I have to agree, I felt like the first real introduction for me with Hubble was when I saw the first deep field in the mid-90s, and I saw and I understood what that image meant and how it was taken. That's when I first got into Hubble a lot. And the other stuff, I had heard about it on the news, and I had heard all the problems with it, but it went by the wayside after I saw the Hubble Deep Field. So anyway, that's so Carolyn, how would you characterize the news coverage now of Hubble versus back then?
Well, I don't see too many people writing about what it cost. I mean, I'm now part of the media, so I get to write about it. But the media now is so strung out. I mean, you have the mainstream media, you have online media, new media, and those of us who do a lot of the work basically take Hubble's pictures, we put them into our videos, we put them into our stories, and we use them. One thing that I've seen is that you'll see people writing about new observatories that are coming out that are going to be just as good as Hubble or better than Hubble, when you would not have seen that 2 decades ago. You know, nobody would have said that. I remember that from Gemini because I did some projects with them, and they were saying, oh, we think we can do better than Hubble. And I thought, well, Hubble's arrived. You know, it's now a good comparator. But I think today it's just it's another great thing, and now it's more focused on the science. I'm going to go back to the comment about the servicing missions. When we were probably at the darkest moments at the university, some of the astronauts who were going to be working on the mission came out for some training at Martin, I guess it was still called Martin Marietta at that time. Claude Nicollier and John and some of those people, and they came out and they met with all of us, and they basically plighted their troth to us, saying we're going to do the darn best we can to make it happen for you. And I think that went a long ways towards helping us individually feel it. I mean, you had to feel it. On our team, it was like grief. And not too long before that, we'd lost Mars Observer. We had a team that had been on Mars Observer. I forget when that was lost, but it was a few years before that.
That was the one that crashed, right?
Well, we don't know what happened to it.
Okay.
But you know, basically one day I'm walking down the hallway, one of my professors walks up and he said, we've just lost Mars Observer, and he was in tears. It was like you lost a family member, and we felt the same way about Hubble. I mean, Hubble still feels like my baby because, you know, we grew up with it. So there's a lot of us who, you know, hug that Hubble as tight as we can. But when they came out and told us we're going to do the best we can, we really appreciate, you know, your faith in us. I mean, it went a long ways towards helping us. Then when they actually went out and did it, as she just said, it's amazing. It was just amazing. I was at the Cape watching that after the launch, and we just were glued to the TV for days watching it.
Yeah, that's a great story. So, Antonella, tell us a little bit about. We hear a lot about NASA and ESA together when it comes to Hubble. Can you give us some idea of what ESA's role is?
Right. Well, ESA was there since the beginning because, in a sense, if you remember the very, very old history, Hubble was born as a 3-meter telescope, was called the Large Space Telescope, in the beginning of the 70s. But then, as soon as people started, NASA started doing feasibility studies, they realized the mission was very complex. And, listen, that the cost was going up and up and up. And what's new, right, under the sun? And so Congress basically instructed NASA to descope. That's why we have a 2.4 Hubble Space Telescope.
Descoping, that's where you basically roll back different features that you thought you were going to make.
And make it smaller, right? And also they were encouraged to look for international partners to share the cost. And ESA was actually coming out from a very nice partnership experience with the International Ultraviolet Explorer, IUE, where ESA and NASA had partnered very successfully. So and ESA was potentially interested to play a role in the Hubble. And so the partnership basically was started then, and there were a few years of negotiation. But by 1977, a formal memorandum of understanding was signed. And that basically stated that ESA was going to provide some hardware, and these were solar arrays and the faint object camera, one of the imaging instruments, and a complement of people to support the mission in what at the time was expected to be a sort of 100-people institution to support the Hubble. And so when STSCI, started in the 1980s, at the same time when we had, U.S. scientists, we also had ESA scientists already on the premises, and we have kept 15 scientists, here in Baltimore supporting the HST mission since. So I think that ESA, they're very happy to have been such, a reliable partner for all these years, and they have enjoyed the return, which is, the European astronomical community has access to 15% of the, of the time, which, is won competitively anyway, so it has never been enforced, but that's what the MOU says. And
you're allocated 15% of all Hubble time?
Well, every year when there is an allocation, we make sure that European astronomers receive, 15%. It's averaged over the lifetime of the mission, but that's what the MOU would say.
That's interesting. I did not know that. Okay, so when the time allocation committee meets, they have to meet certain requirements, and one of them is that maybe.
But I can tell you that
we
never had to enforce it because it's basically people win competitively on the. Now, if you look at how science has evolved over the years, now all collaborations are international.
Yeah.
So, you cannot even, go and distinguish, who belongs to what.
Right.
I was gonna actually say that we don't talk about that very often. We talk a lot about the benefits and how Hubble has changed the way science is done. We've talked about that with the Hubble Deep Field, but I think also the fact that we collaborate and we have people at the Institute who work, hand in hand, has really, I've been there 19 years, and it's just part of the culture. It's just the way it is, but it's really amazing, and I think it's really been beneficial. Yes. It's really changed things, I think, than if it had been just an American endeavor.
Okay, so let me see here. We got a question from Vance McCauley who's going, thanks for putting this great panel together this afternoon. You're welcome. The entire HST design and retrofit missions are amazing to me. I wave at both HST and ISS when they come.
So do I.
Yeah, exactly. Okay. We lost
Tony froze.
Tony is frozen. Oh dear.
Oh dear.
Oh.
Well, let's see if he comes back.
There. I think it's this Google Plus Hangout, the plug-in, because I just upgraded it.
Oh, bad idea.
It hasn't worked great.
Bad idea.
Well, it won't let me do anything else. You know how when you switch from one window to another, it keeps popping up until you upgrade it? So I did it right before the Hangout, and I'm wondering if that's not screwing up. I should have probably closed my browser before I started it. But anyway, my apologies if I freeze up again. So okay, so the what was your, and how did you get involved in the Hubble mission itself? What was your first experience?
I was in Europe. I just got my PhD, and I was looking at job offers here and there, and this opportunity to come and work on the Hubble popped up, and for me it was just leaving Europe, moving to a different continent, but I was an adventurer then and a traveler, so I said, yeah, I'm on. I mean, I'm just. And this was it. And the interesting thing is that I arrived in January '86. There was a big rush to get ready for launch because we were, one shuttle launch from our, launch mission. And then, unfortunately, in January, the Challenger blew up. So that was a horrendous moment that we all lived, especially because we were just watching, like, this is the one last mission before we go. And so then everything was put on a, slower pace, which was, a good way to get readier for the actual launch in 1990. And I was a postdoctoral fellow working on the faint object camera, so that was my role at the time. So exactly like Caroline was worrying for the GHRS, I was there worrying about the FOC, and the FOC, being an imager, the spherical aberration was so visible and painful, right? Because spectral, okay, you lose your sensitivity, you lose your photons. With images, the brutality of the Strel ratio, of the center to halo light ratio, was just brutal. And I think that instrument sort of never recovered from being hit so hard. But then, then there was the resurrection with CoStar and the brilliant idea that engineers and scientists had working together to figure out this complex device that would, basically deploy little corrective arms in front of the apertures of the spectrographs and actually restore pretty much. Caroline, in your case, I think, GHRS worked pretty well after.
Yeah, we weren't throwing away half our data every time. So,
right. So I think it was a collective, again, talking about the international nature of the mission and also of the rescue mission. People really, worked really amazingly well together to try to figure it out and fix it. And then the astronaut, of course, did it, installing CoStar and making it happen.
Yeah, the astronaut did it, but we all know where the real work was. That was before it was ever launched. So you mentioned earlier that ESA had built the solar arrays that were first launched with Hubble. Did they build the subsequent replacement arrays, or was that done? So that was just a one-time thing.
Yes.
Okay, so the ones that are on there now have not been built by ESA.
No,
okay.
They are not, because the one that were built by ESA had a problem. They were too stiff, and so during the terminator, during the day-night transition, the thermal tension would create some, how can I say, shakes to the telescope, which were really not something you want to see in your observations.
No, you don't want to vibrating and shaking it.
You live and learn. You design something, and then you're faced with a situation in space that is different from what you knew, and then you have to adapt and design a new set of solar array, which can overcome that issue.
So we had a hangout a few months ago with the guys at Goddard who actually operate the Hubble Space Telescope, and does ESA have a role in that at all, or is that pretty much done by NASA? Okay, so what is ESA's role these days? What do you guys find yourself doing mostly with the mission?
We basically provide 15 scientists who are basically allocated to support the mission. Most of them are instrument scientists. So they work on, calibrating and user support for the various instruments on board of the telescope. The interesting thing of how the agreement was stipulated at the beginning is that our staff is fully integrated. So they can, provided they are staying within the Hubble mission at large, they can, move wherever the skill set brings them. So I was head of the Science Mission Office for a while, for example, but most of my colleagues and my team members are all instrument scientists. But we had archive scientists in the past. We never had anybody in outreach. I think that's something.
The outreach efforts that I've been involved in with ESA have been with the ones that also do other missions as well, like ESO and
yes.
A few other things. So the people there are awesome, and those are also the ones who have organized and implemented this video contest that we just talked about. So
they are part of my team. Yeah.
Go ahead, Carol.
So I have a question for Carolyn. So we've been talking sort of with, because many of us are here at Space Telescope, we've been talking about this sort of Baltimore-Washington centric, what it was like. You guys are out in Colorado and you're seeing this disaster. I'm just wondering, like, what your perspective was then, and then how that's changed, and it must have been pretty frightening to be a little bit. Did people fly to NASA or what? What happened?
Oh, I think Jack flew out right away. In fact, sure. I believe he was tasked to be out at NASA for the first 6 months anyway, or in the Baltimore area for the first 6 months after launch anyway. But he came back, and we knew. I mean, we sort of knew when some of the first images were sent down. We all looked at it, and everybody kind of knew this was going on, but there was a lot of denial going on at the time about. Well, Sandy Faber basically said they had to just stand up and shout at each other at meetings. And when I think it was Tony Angel or Dr. Angel stood up and said, "This looks like spherical aberration." She'd been saying it all along. He said she said that's when we knew we were well and truly dead. She's telling me this like 4 years or 3 years after the fact. At that point, which was second, third week of June, Jack made a special trip back out to Colorado, gathered us all and said, "We know what we think it is. And we'd all been talking about it. You're not to talk to the press. Let the Space Telescope Institute handle it, because you guys were sort of at ground zero on that, and you were having to formalize it. I mean, basically come up with a response for all of this, and it would not help for all of us out in the field to say anything. That being said, we did get a lot of phone calls from the press locally, and we would say things like what we knew we were allowed to say, we would say. Otherwise, we'd have to defer it to the Institute.
So then, how does the team get past that, and then the participation now, and once it was fixed?
Well, once it was fixed, we were dancing. I mean, we were getting data. We weren't throwing half of it away. The deconvolution algorithms, we'd been able to pull things out before that, so we weren't throwing it quite away. When I got back re-involved with it quite heavily, because for a long time there was nothing for me to do, I came back in and I was helping to figure out how we were going to apply for time and what we were going to have to do to make that data work for us, and with the pipeline processing and all that sort of stuff. We were very busy working on that, so we were focused on something that we knew would help make things better, and that really helped a lot. That this is a future thing. This is not over dead in the water. Then when the first servicing mission results came back, everybody was pretty much dancing, and at that point, I remember it was like, okay, it's more routine now. I mean, there were still problems, obviously. I mean, there were, we had problems with submitting proposals and all this, but we got it done, and we got people being able to say, "Oh, geez, now I can finish my PhD thesis." Yeah. Because one of my partners in the office was working on Alpha Ori, and it's like, "Oh my God, how am I going to do this?" And then a couple of years later, when Dave Leckrone did all the work on Chi Lupi, that was sort of like the gold standard. So to explain that, when Dave Leckrone used the GHRS to look at the peculiar star Chi Lupi and saw many, many chemical species in it that normally had not been seen in stars before. Could not have been done without the work that was done on GHRS, and he won an award for that. I think that was a vindication, and we talked a lot about that at the GHRS results conference we had a few years later. So we actually were able to put together a book. I have it back here. It's a book about that thick now of all the results that we did of the first several years of GHRS data. So at some point, I think right after the first servicing mission, it was like, okay, full speed ahead, let's go. We know we have a few problems, but we can put the oars in the water, we can go.
So, Carol, let me put that same question back to you then. What were things like at the Institute?
Me? You're asking me? Well, I was in the outreach office, and I actually didn't join the project until the telescope was fixed. So.
Oh, okay.
Oh, so I see. Carol is the master at risk aversion.
Yeah. Very smart.
No, I was working on the Extreme Ultraviolet Explorer.
Oh, okay.
At that time in California, and I got teased over to Baltimore, you know, a garden spot of the Mid-Atlantic from California. So,
well,
anyway,
California
so
is high.
Yeah, oh,
we miss you.
Great. Anyway, so I joined the Office of Public Outreach, and actually I joined it just when the first image came back from the servicing mission, and it was great because at that point everybody was. It was like, oh my God, this worked. We had this telescope.
Yeah. We were practically in tears.
Fantastic. You know, it was really fantastic. And from the community side, I had been, because I am an optical near-infrared astronomer by nature, but ground-based, we all were watching, and participating in how can you take the imagery and do this image processing, this complex image processing, as Antonella talked about, the core, you could get the core of the image, but then there was all this scattered light, and you know, can you process it, and people tearing their hair out and making algorithms to see what they could get out of it, and they could tell that the telescope had a lot of promise because those cores were, you know, they were pinpoints, and it was like, man, if we could have that, we're golden, and then it happened, and so. It was just great, and so people were learning how to. Then you have the normal situation where you have a telescope as if it's brand new, and you start learning how to calibrate it and get the most out of the telescope. Of course, you want fantastic early results, and then you start combing through all that data to get every little bit out of the data, because then the data was exquisite. And then it was easy. You made these images, you said, and keep putting them out. The public then is starting to support you, and you know, then they were willing to understand that we could do even better by upgrading the telescope even more times. So it was a really exciting time. It still is. I mean, it's still great. I mean, I think of it as a brand new telescope. It was serviced in 2009. To me, it's practically a 5-year-old telescope, not 25.
Yeah, one of the interesting things too is from all the work they did on the deconvolution algorithms and the work to pull that data out, it actually went and benefited other instruments too. Ground-based as well as other telescopes. So it was work that, you know, at the time now serendipitous. It sure looked like it was a pain at the time.
Exactly right. So it's a good technical contribution to science in general. Yeah.
All right, well, that's really great. So I don't see any questions or comments on the...
Actually, I've got a great comment here.
Oh, okay, go ahead.
From the event page. It's from Sev Despany. It says, for me, I feel that
Sev.
Pretty much all of society cannot help but appreciate the HST, as not only is it clear what it has done for science and the understanding of our universe, it then provided images that allowed everyone, even those with no interest in science, to marvel at the beauty and wonder of the universe, and inspires a new generation of scientists.
That's
and
true.
That complements our show. But I can't agree more. I think that I know it inspired me. I know that I'm the youngest one in this hangout, but it's been something I've talked about before. Oh, Carol's a close second.
All right. Yeah. Fine. Fine.
But it's something that I feel, very proud to be able to help tell the story of, when it was something that had always inspired me. Being able to see these beautiful images and now having this privilege of being able to be a part of it, I absolutely love it. And I know that many of my friends and colleagues that are out here in California as well, even though they work in planetary science, because most of them are at JPL, they tell all the time that Hubble had inspired them to get into science. Even though they're doing something completely different, it still got them into space and wanting them to find their own passion of exploring space. So it definitely has some.
You do see Hubble pictures show up in interesting places. I think maybe one of the other hangouts I mentioned that, if you watch Star Trek The Next Generation, Star Trek Voyager, some of those images showed up largely because of Andrei Bormanis and his love for it. He would say, let's get these on there. You see them all the time in many places. When I give a lot of lectures on board ship, and if I do a Hubble talk, it's like an instant hit. You know, it doesn't matter what it is. I could show the same talk 5 times. Everybody's going to show it because they really want to see it.
Right. Well, and one that we just had a few weeks ago, and one of my friends, Carrie Bean, she's on the Dawn mission.
Oh,
and they just released their highest resolution of series ever, but Hubble was used in collaboration with those other missions as well. And she was always telling me about how Hubble had inspired her, and now she was able to use Hubble data to help take pictures, to point the spacecraft at Sirius, and now surpasses in resolution for Sirius. So I think
a lot of PhDs out there with Hubble stuff.
How far and wide Hubble has been able to inspire people.
I think that's been a little bit of a surprise, is that people don't think of how much science has been done on solar system objects. With Hubble, because you always think of cosmos, star formation, exoplanets, deep cosmology, but there has been quite a bit of work, and famously the Shoemaker-Levy object that hit Jupiter was early on too, and that really helped bump up the street creds for. I was going to share a little story. Antonella and I, many years ago, went to Papua New Guinea, and we were on a trip there with the families, and we ran into, one of the guys on the ship, it was a dive ship, he was not actually literate. He couldn't read, and he sort of made a mark for his name, but he could pick Hubble out in the sky. He knew what Hubble Space Telescope was.
That's great.
And he showed us one night, because it was really dark. He was like, here it comes.
There's Hubble.
So number one. Number two, we handed out we had just made a bunch of these little trading cards with galaxies and planets and stuff. And we had a couple packs of them with us, and we handed them out to these little kids, and they were like, oh, they had kind of heard about this telescope. And another thing was we had been traveling around, and we visited a guy who had a coca plantation, and during our tour, he radioed to the captain the observations of the moon from Hubble, the results, which I thought was kind of amazing. After we had met him, we were like, it was kind of like, that's neat, but how did they find us? We were trying to escape work, and it was like, they're sending us work results, and we were like, neat, but okay, thanks.
There's nowhere on Earth you can go, Carol. You can get away from it.
Apparently not.
So Adam Synergy has an interesting question on Q&A. If you were to ask people that don't have a big interest in astronomy to name a space telescope, what would they say? And I think it would have to be Hubble, right? If they're going to name, that would be the one that is most well known. So, but the great thing about Hubble and in astronomy in general, it's always been very easy to get people interested in astronomy because of the content, the material is very accessible, very beautiful. It really captures the imagination. So astronomy has always made it very easy to get people into science, but Hubble has given views of the sky that are just unparalleled. So that is. So we got a couple more questions here. Cecil Morgan is asking, can we use interview excerpts from your Hangouts in our Can we use interview excerpts from your Hangouts in our video for the contest?
Not if you make us say things we didn't intend to say.
I don't know. Out of context, not.
I know that's a scary one, Cecil. I'm not sure. Nikita Net is asking, is HST replacement when needed a must for the advancement of science? The explanation to the general public and/or the enhancement of other projects. The HTS replacement, or is it HST?
HST.
Yeah. I guess that means the James Webb Space Telescope.
And W first after. Yeah.
And W first following that. Is it needed for the advancement of science and explanation to the general public? My answer to that would be absolutely. We cannot see some areas of the universe without the Webb Space Telescope, and the infrared capabilities are going to make us see things that also Hubble cannot currently see. Plus, the size of the objective, the resolution will be way beyond what Hubble can currently do. So,
and I think a good analogy is, going from having just an optical microscope to having a scanning electron microscope. The things that we've learned by pushing our limits of what we can observe with it. So it goes on all scales, and when we're able to observe things in a deeper way, so now we're getting to look at longer wavelengths with JWST, it has worked the same way in the opposite direction. So the further we can reach into observing the universe in any direction, I think is going to help the advancement of science.
Good.
Well, I also will say that Hubble makes it, I mean, any telescope makes advances. We do these observations, and so we get some answers. We do build models. We say, okay, we think it's like that. But you know what? What about this other part? Or, you know, what about if we looked back a little further? Or can we actually resolve those disks around planets? So for every breakthrough and discovery we have more questions. We want to know things in greater detail. We want to have better models. So that science doesn't stop with one telescope.
And we know everything.
Well, I thought, that's what I thought. We knew everything about the universe for a while now. So.
Sorry.
Don't forget, the Hubble is a small telescope.
Yes.
It is.
0.4 meter. It's comparing even to the ground-based telescope that we see now, it's a small telescope. So if we want to go deeper, farther, more sensitive, we need a larger telescope in space. So JWST will be larger. We need even larger telescope in the future if we want to find life out there, for example. So something to think about.
That's true. All right, Scott, have I gotten everything? Do you see anything else?
I believe I have everything else taken care of that I can find.
All right. Well, I guess we will wrap it up there for this week, folks. I want to thank Carolyn Collins-Peterson and Antonella Nota for joining us. Thank you both very much. This has been a lot of fun. And
thank you.
We will be back next week, where I think we're talking about Jupiter.
Yes.
I believe, is that right, Carol?
Ooh,
okay.
Yes.
We're still finalizing the exact time. We're still working on the calendar, but it will be about some images of Jupiter and solar system objects. So they definitely want to come back and see us for that one. And don't forget about the video contest starting on Monday morning, and submit your entries early and often, and have it be crowdsourced and whittled down, and hopefully you'll win a piece of the solar panel. Anyway, that's it for this week. Thank you, Carol. Thank you, Scott.
Not a problem, Tony. See you next week.
Thank you.
See you guys next week. Thank you for watching, and as always,
keep looking up.
Keep looking up.
Up.
And Scott, I believe, has a trailer that he's got queued up.
Oh, yeah, I'll do that now. I didn't know we were doing it so soon. Just one moment.
To celebrate 25 years of a truly remarkable telescope, its staff and its fans, we're pulling out all the stops for 2015. Join us by being part of our biggest competition yet. Ode to Hubble will launch early next year and give you the chance to get creative and show how Hubble has inspired you. As long as it can be uploaded as a YouTube video, you can submit anything. Pan over a drawing, scroll over a poem or text, film your own Hubblecast, create an animation, or record yourself performing, composing music, or vodcasting.
About this contest.
Well, there is a website, is a Hubble, www.spacetoLescope.org. The people should look, and there will be instructions. But basically, the competition is opening on Monday. Will be out open for a month and a half. And our hope is that people will respond and will be able to have a great selection of creative videos and music and paintings, because we want to select the winner and announce it, actually 2 winners, on Hubble birthday. And the winners are, there is a general category winner and there is an under 25, because we felt it was really important to see what the next generation that is born, who was born with Hubble already in orbit, thinks of this amazing telescope.
Right.
And,
we'll call it.
Just make it innovative, creative, and most of all, inspired by Hubble, one of its great discoveries, or one of its stunning images.
So there you go. There's the trailer for the contest. It's going to be launched next week. You can watch the full video over on spacetelescope.org. They have a Hubblecast section, which comes out every. How often does Hubblecast come out, Antonella?
You know, when we have material to show something around, pretty much every other month. We have 81 in the library so far since the beginning.
So these are really nice videos that sort of keep you up to date on Hubble news and all kinds of cool things. But this one is the one they made last year. It was made in December to sort of get people ready for this video event. So we hope you'll participate, and we hope you'll go looking for the information. In fact, Antonella, let me bring you in on this. How can people learn more? Hello, everybody, and welcome to this week's Hubble Hangout. My name is Tony Darnell. I work at the Space Telescope Science Institute. And this week we are continuing our celebration of 25 years of the Hubble Space Telescope. We're going to be talking a little bit with author Carolyn Collins-Peterson on the history of Hubble, as well as Dr. Antonella Nota from the European Space Agency, who will give us insights into the European Space Agency's role in the history of Hubble. But before I do that, I've got to let you guys know how to. We hope that you will send us questions and comments during the Hangout in the following ways. Tweet at us. You can tweet at us using the hashtag Hubble Hangout, as always. We're also the easiest way is to also just use the Q&A app, as well as the comments on the YouTube channel this is being broadcast in. So please feel free to leave us questions and comments throughout, and we will get to them as they come up. And also, if you have not subscribed to our YouTube channel, we hope you'll do that. It's Hubble's site channel. Also follow us at Hubble Telescope on Twitter. Okay, so joining me as always is Dr. Carol Christian. I'm going to do this throughout the Hangout.
Are you breaking in a new set of lips over there?
Carol Christian, the outreach scientist for Hubble for the Space Telescope Science Institute.
Hey there.
And Scott Lewis, our driver of the Internet extraordinaire. Welcome back, guys. It's good to see you again. So, as I mentioned before, we have an author and a scientist to talk about the history of Hubble, but there is also an opportunity coming up next week for you to participate in the 25th anniversary of Hubble Space Telescope. The European Space Agency next week is launching a video contest to allow you guys to express yourselves and to get involved in the celebration of Hubble.